Continuing on with our 11.7 lesson, we're going to be looking at how to expand binomials with irregular terms. And by that I mean like this term here, it's 3x. It's not just x, it's not just 3, it's a 3x. So it's going to be a little bit of an irregular term for us. But we still go about solving it or expanding it the same way we would before, where the first thing we need to look at is our exponent. That'll help us find our row, so we know we're in row 4. So we're using these numbers here. So we then go on to say our coefficients are going to be 1, 4, 6, 4, and 1 as given from our row 4. So these ones right here. Next thing we need to look at is whether it's positive or negative in between there. That one is minus, so we start with positive and go every other. So minus, plus, minus, plus. Now this is where things get a little tricky. Remember, we look at our first term, so this 3x, and we go in descending order, so starting with that to the 4th power and going down. But it's the whole term, so it's not just x, it's 3x to the 4th, in this case 3x to the 3rd, in this case 3x squared, 3x to the 1, and 3x to the 0th power. So it's not just one piece, it's the whole term to that power. And similarly as before, we do y starting from, or our second term, starting from the bottom at 0 and working our way up to 4. So y to the 0, y to the 1, y to the 2, y to the 3, and y to the 4th. Now from here, we solve it algebraically. So it's going to take maybe an extra step or two. We would say that 3x to the 4th power, we'd have to apply the 4th to both of them. So it would be 3 to the 4th power times x to the 4th power. So it's actually going to be 81x to the 4th. Same way, this 3x to the 3rd power is going to be 3 to the 3rd power, x to the 3rd power. So this one is going to be 27x cubed. This one is going to be 9x squared. This one is going to be 3x. This one will just be 1. So now we've taken care of what each individual green piece, so our x terms, come out to once they are taken to the power. Now we just continue on as we did before. So 1 times our x term, which is actually 81 x to the 4th, times our y term. So our first term in the end actually comes out to 81x to the 4th. Our second term would be 4, or should I say negative 4, times 27x cubed times y to the 1st. So that one is actually going to come out to negative 108. That's our coefficient x cubed y. And that was negative 4 times 27, got this coefficient here. Going on to our next one, 6 and 9, positive this time. So it's going to be positive 54 x squared y squared. This one is going to be negative 12 x y squared. And this one is going to be just positive y to the 4th. So our coefficients, these ones, the 1, 4, 6, 4, and 1, still come into play, but they are affected now by these pieces, the 3, 9, 27, 81, that we got from right here, that irregular term there. But in the end, this is our expanded binomial. So what do we do then if we are given, if we are given our binomial expansion that we're looking for, and we're asked only for a specific term? So in this case, we're looking for the 4th term. We would have to set it up the same way as we have before, but we can kind of eliminate things we don't need. So I'll show you what I mean here. If we're in the going to the 4th power of this binomial, so we're in the 4th row. So we set it up the same. We look at our coefficients 1, 4, 6, 4, and 1. I'm not giving myself as much space this time because we won't need as much. We set it up again the same as check for our sign. Everything is going to be plus. And then we look at our first term, a, and we start at the top, say a to the fourth. This one would be a to the third, but I don't even really need to write it in because we're not looking at that one. In the end, we're only going to be looking for the fourth term, 1, 2, 3. This piece is the only one we need. So we'd have a to the fourth, a to the third, a squared, and a to the first goes right here. Similarly, if we have 3b here, it would be 3b to the 0th, 3b to the 1, 3b to the 2, and 3b cubed right here. Notice I'm not writing anything over here. We don't need it, and we don't need any of these terms. I used them. I wrote them in just to keep my place value so I know where I'm at. But really, in the end, all we're looking for is this piece here. And we've got everything we need. We just have to solve it out now. So 3b cubed. So 3 cubed is 27. B cubed is b cubed. So we're looking at that piece times a to the 1 times 4. Okay? Now from here, 4 times 27 is 108. A to the first power, b cubed. So our fourth term of the expansion is just going to be positive 108 ab cubed. And that's all we need to know. So it's a lot quicker than foiling everything out and pointing at this one as our fourth. So that's how we would do expansion of binomials using Pascal's triangle. Stay golden.